Good morning to one and all. Here I am going to present a topic, computer arithmetic operation. We already know about what is meant by computer. Computer is an electronic machine that can access the data from the user and accept the result and process the data and produce the desired output. That is the meaning of a computer. So we describe about computer. So next one is, what are all the available components of our computer system? So in our computer there are 5 major components available in our computer system, that are input unit, then output unit, CPU again divided into data path unit and control unit. This is our components of our computer system. So here components of computer system is divided into 3 types. First one is input unit, output unit, CPU. CPU is again divided into 2 types, data path unit and control unit. CPU is our brain of our computer system. So here data path unit it can execute the data transfer instructions. So control unit can overall coordinates the execution of our computer. This is the major components of our computer system. Next we are moving to computer arithmetic operation. What are all the available operations in our computer system? So these are all the available arithmetic operations in our computer system, that are addition, subtraction, multiplication and division. In our system it can only understand the machine level language. It's only in a binary form, zeros and ones representation. So we have to convert any data into binary represented format. For example, if we want to convert it, 5 is a decimal number representation. If we want to convert into binary form means you have to divide the number by 2. So you have to divide the data. This is an equivalent binary value for decimal number 5. This is a conversion for addition to binary value. So next one is subtraction. For any value we have to subtract. There is in 2 formats. One, we have to add in a direct binary subtraction, otherwise we have to subtract using the 2's complement subtraction. This is an 8421 methodology for binary form conversion. We have to convert decimal into binary form representation. In that we have used to convert binary form into some other formats also, such as octal and hexadecimal conversion. So here I have to convert using the 8421 methodology. In that I have to convert 5 into binary form representation and 8 into 8 into binary form representation. How to add these 2 values? How to add 5 plus 8, 1 plus 0 is 0, again 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1. So we have to check what is the output? So 5 plus 8, the value is 13. Again we have to check the answer. So the value is equivalent to 12. Our answer is satisfied. Next I am going to perform the binary subtraction. How to subtract the value from 8 minus 5. This is the direct subtraction method. I have to subtract 0 from 1. There is no possibility. Have to borrow value 1 from these. So 0 minus 0, 1 is 1. Again the zeros will changes to 1. This 1 is changes to 0. This is my corresponding result. 8 minus 5, the value is 3. So this is a binary subtraction. So we are going to discuss binary addition and binary subtraction. Then we are moving to binary multiplication. How to multiply value 8 and 9. Zero into any number is 0. This is our binary multiplication. How to multiply value 8 and 9. So I have to add the values. The final result will be 72. So I have to check the result using the 8421 methodology. I have to check this value. 64 plus 8, the value is 72. Normally you have to multiply 8 into 9, the value is 72. Okay, this is a binary multiplication. Next I am going to write a multiplication algorithm for sequential hardware. Okay, this is our multiplication algorithm. Before discuss about multiplication algorithm, how to move on multiplication hardware. This is a sequential version of our multiplication hardware. It will contain a multiplicand, multiplier, ALU and product. So these hardware diagram, multiplicand, ALU and product, it occurs 64 bits, but multiplicand it can only occupy 32-bit representation. Why means multiplicand represented using the 8-bit. Similar product, it will occur the result. Multiplicand have to perform in the right shift operation, that's why it will occupy the 32 bits only. This is our sequential version of our multiplication hardware. Control states its overall control the process of our multiplication hardware. Next we are going to move on the multiplication algorithm. First we have to check the multipliers bit. It will be equivalent to 0 or 1. 0 means there is no operation. You have to shift left multiplicand and shift right multiplier. Then check the repetitions. If 32 repetitions is over means we have to stop the process. Otherwise move on to the 32 repetitions. Otherwise we have to move on product equal to product plus multiplicand. Next we have to store the result in the product. Next we have to perform again the same operation, left shift and right shift. Next we are moving to an example. Two is equivalent binary value is 0 0 1 0. Here 3 is equivalent binary value is 0 0 1 1. An example, herewith I am going to multiply the value 2 and 3. In this I am going to convert 2 into binary equivalent form and 3 into binary equivalent form. This is my first iteration, this is an 0th iteration. I have to initialize the values. What is a multiplicand and multiplier, what is the product value? Product is initially 0. Next one I have to perform the corresponding operation. So here with I am going to execute my first iteration. I have to check test the multiplier. The multiplier last but is equivalent to 1. Have to execute the following instructions: product equal to product plus multiplicand. Have to add product plus multiplicand value. Next step, have to shift left multiplicand by 1 bit. Next I am going to perform the right shift. In that shift left multiplicand, you have to shift left by 1 bit. Shift right multiplier, how to shift right multiplier by 1 bit. This is my first iteration. Herewith I am going to second iteration. Again the multipier's last bit is 1. Again I have to perform the following operation. Okay, this is my second iteration. In that I have to add product plus multiplicand, then place the result in product. Next I have to shift left by multiplicand value. There is a shift left logical. I have to shift left 1 bit by multiplicand. Next I have to shift right the multiplier value. In that 1 is moved into carried value, that will be replaced by bit 0. So herewith I have to perform my third iteration. In that I have to check multiplier's last bit, it's represented as 0, so there is no operation. So herewith I am going to perform no operation and shift left multiplication and shift right multiplier. In that herewith the final product is equivalent to 6. So you have to repeat these steps into n number of iteration. For multiplication, n bit means there is an n iteration. You have to perform, for example, there is an 4 bit multiplication means there is an 4 iteration. It's an 8 bit means you have to perform 8 iterations. Okay, this is an example for multiplication. In that product only how to get the final value. So similar division also, there is a division hardware is available. There is also a division algorithm is also there. Here there is a division algorithm. In that we have to first check the remainder equal to remainder minus divisor. This is a basic operation. Next you have to check the remainders first bit, that is an equivalent to 0 or greater than 0. If the value is greater than 0 means you have to restore the original value in the remainder value, then shift left logical to the quotient register and set Q naught equal to 1. Otherwise, if the remainder bit is less than 0 means you have to perform these following operation. How to perform shift left logical in the quotient register, set q naught equal to 1, then perform the shift right divisor by 1 bit. Next you have to perform 33 repetitions. Up to 33 repetition we have to perform the division algorithm. Next we have to stop the process. In that multiplication, for n bit in multiplication we have to perform n iteration. Similar division, n bits means we have to perform n plus 1 iteration. That's why we have to perform 33 repetitions here. In multiplication we have to perform only n iteration. If it is in 4 bit means we have to perform only 4 iteration. It's in 5 bit means we have to perform only 5 iterations. Similar division, it's in 4 bit operations means we have to perform n plus 1 iteration. For example, it's in 4 bit means we have to perform 5 iterations in the division. This is the division algorithm. Based on this, you have to perform a division example. Okay, this is my first iteration. In that I have to restore in my original value and shift left logical in the quotient register, set q naught bit is equivalent to 0. Then again have to shift right the divisor value. Again I have to repeat the same operation, remainder equal to remainder minus divisor. Then I have to again perform the binary subtraction. This is my binary subtraction. I have to place this value in the remainder register. The next step I have to check the condition, check the remainder bit, it's equivalent to 1. Again I am going to restore the original value and shift left logical. Set q naught is equivalent to 0. This is my second iteration's result. I have to shift right divisor register. The third iteration also have to perform these step and the default. So again have to subtract remainder and divisor value. Have to subtract remainder from the divisor. One is 0 is replaced by 1. Again repeat the same step. Set quotient registers last bit is equivalent to 0. Okay, in the third iteration, I have to perform the again same step, remainder equal to remainder minus divisor. How to get this value? Again, I have to check the remainders last bit. Again, I have to perform the restoring operation and shift left logical in the quotient register. I have to set Q0 value is equivalent to 0. There is in 0. Next, we have to perform the shift right operation in the divisor register. How to shift one bit by in the divisor register. Next I am going to repeat the same step, remainder equal to remainder minus divisor. In that fourth iteration only we have to get reminders last bit is less than 0. In that we have to perform only the shift left logical, then set q naught is equivalent to 1. Next we have to perform the shift right divisor. Similar we have to perform the fifth iteration. Okay, there is my there is in my fifth iteration. In that I am going to again repeat the same step. In that step I have to set quotient register last bit is equivalent to 1. Then I have to perform the shift left logical operation. In that final I have to check the remainder value is equivalent to 1. In normal division, in that you have to check your remainder value and your quotient value. In my quotient have to get the value 3, have to check the result, that you have to get the value is 3. My remainder I get to get the value is 1. Okay, this is my division algorithm. Thank you.